and landscape and so on. So here is an example how the technology can be used in completely different area in different project. So maybe I'm beginning few words about Cape Verde. Maybe some of you remember I presented 4 years ago the results of a national forest inventory on Cape Verde. So there is just a few information. The Cape Verde are located near Africa. It's 10 islands, and 9 of them are the people live on the islands, and it's extremely dry island, so there is a very big problem with the water. So some data from inventory. So the total wood volume is 960,000 cubic meters, and the woodland area is only 89,000 hectares, and new growing stock is 10 or almost 11 cubic meters per hectare. So compared to Czech results was 360. How much was in Czech? This mean growing stock in Czech Republic.
Yeah, 329.
329. So it's you see the forests are very very poor. So there are some pictures how the islands looks like. Of course, each of the islands looks a little different, but here you can have at least some clue how dry are these islands. The main species is the prosopis. This species was planted in the 70s, and now is dominant. So 60% of all the trees in Cape Verde are this species, Pinus prosopis. So we were hired as a consultant in the big project called Water Sanitation and Hygiene Project. So this project was funded by US Millennium Challenge Corporation. So the budget of the project was quite big, and our part was very, very small in that project. And so the aim of the project was to clean mess all these institutions. So because there is a lot of institutions in Cape Verde, a lot of projects, and each of them have some data, and they are not cooperating to each other. So the main aim of this project was to reform this national policy and make the cooperation of these institutions, and also develop some central database where will be all the data collected regarding this water resources, and so that's how we came to this project, because on the Cape Verde is now quite a lot. So there are some former users of Field-Map in Inventario, so they know the technology, so they decided, they found out that this technology can be useful also in other area, so that's why we were hired.
Okay, so our mission was actually very big. We are hired to help them with creating Field-Map project, which was based on their methodology. So we came there to design their database, start using this project, so collect some data and merge them into one database, into one Field-Map database. And we also delivered some computers and train the workers to use Field-Map. So we had some planning. We had some phases of our mission. The first one was to develop a methodology, but this was done by an external consultant, yes, Portugal. So we applied this methodology, basically developed the database for Field-Map. Then we trained some Field-Map experts, because this project is supposed to be developed further by local staff. So we trained 2 people how to use Field-Map and project manager, how to change the project structure and so on. Then after we prepared the project, we had some project validation, so we actually tried how to work with this project in the field and made some changes based on this field testing. Then we trained several field workers. I think at the beginning of the project they should have 4 teams to collect data in the field. And also this project should use synchronization, so we set up this server. Then we have 2 more steps which are actually not part of our work, but those are steps that the ANAS is supposed to carry on with. And that's data collection, and then after they collect the initial data, they are supposed to continuously monitor and improve this infrastructure.
Some few words about the methodology. As Vondra said, it was not our work, but our work was to implement the methodology to the Field-Map structure. But the water resources was split to 4 main groups. So the clean water retention, G wells or dams. Then there was a water supply system, like pipes, water pipes, residual waters, and in the end monitoring. So the system was developed that can collect data repeatedly or continuously. So they on some water resources they collect data every week, in some every month, in some of them they visit once per year. So all for everything that's being prepared. It was 23 total subtypes of the water resources on the Cape Verde. So here you can see some example of the structure of the database. So it was quite complex.
I counted this database, in a project, it has about 50 layers and 700 attributes. So it's not a small project. So and our main task was to do a lot of scripting in the Field-Map because there were a lot of conditions how these forms should appear and who can collect such data. So in the end of our mission was developed a new application for the ANAS, for this institution, where they can collect all information and also prepare some exports and some outputs for graphs and so on. So other step was, so the first step was to design the database, structures and design the application. Then we have to prepare, let's say, the database because each plot in Field-Map is represented by one island. So together there is 12 plots. And each island is split by different districts. So all these areas and all these polygons of districts was put to the system before we leave the Cape Verde. And also there were already existing data. So they have a lot of data in paper format. So this data, of course, we could not put to Field-Map, but they also had a lot of data in Excel or in Access. So we also have them to import existing data to the system. So they didn't need to start from scratch from the beginning. So so they collect different data from different institutions and to put everything together. Okay, so we suppose the basic Field-Map project manager and data collector to be used by the staff, and also the first it was for GTAC T800 computers without any external devices. Actually, for navigation and for measurement, only thing that they are using is GPS. And they are using this integrated GPS results.
So some I think is done by GPS, some is done only by pen, and at this moment they should have around 8 teams because the institution, this water agency, bought 4 GTACs. But the other agency take care about the first inventory had another 4 GTACs, so but inventory is not running now, so they help them, so they operate together, so up to 8 teams is now working there.
For example, on this picture, there is this is called piezometer. This is one part of the infrastructure which is used for monitoring underground water levels. Okay, so this is quite a big well, which was actually handmade, and it's in the rural part of the Santiago Island.
So before we left, we make this validation of the system in the field. So we measure several different types of water infrastructure. And the last step was training of the local people. So after everything was set up properly, so we made the training. So all the mission took around 10 days or 12 days.
Yes.
So the first few days we had just to be familiar with the methodology. Then we had 5 days to develop the structure and the scriptings. And the last 3 days was for validation and training of the people. So the results.
So this project was actually quite ambitious, and it's still ongoing. So we don't have any actual results yet, but they expect to improve this water results infrastructure by having this complete inventory. So they will actually know what they have and what state it's in, and these data should be used for planning and future management and expansion of the infrastructure. And also there is this idea that they will use Field-Map and those field computer to continuously monitor water levels of groundwater on the whole island. So they will actually have a map that will show how are the underground water levels doing.
Okay, thank you very much for concise presentation.